welcome back to the Teach Back Method, where I teach you guys something I'm learning about in grad school to help me learn it better. To continue our module of learning and memory, we are going to talk about the best known single patient in neuroscience, HM. Let's break it down. HM stands for Henry Molaison, although in the science community, he's better known as HM. So we're going to talk about his background prior to his experimental surgery. So when he was 7 years old, he got into a bicycle accident, and as a result, he developed epilepsy, which is a seizure disorder. So he struggled with epilepsy for many years, and as a result, by the age 27, he was unable to work. It was just completely debilitating for him. This study was done in 1955. What was removed from his brain? Let's talk about it. So they removed all of the amygdala and the entorhinal cortex. This is important to note because the entorhinal cortex is actually the main pathway for the hippocampus. So although only parts of the hippocampus were removed, it was basically denervated because of this entorhinal cortex being completely removed. What happened to HM after his brain surgery? Overall, the surgery was successful, so his epilepsy symptoms were at bay, but it did cost him. It cost him his memory. So what could he do and what could he no longer do after his surgery? So he did still have his short-term memory intact. If he was doing something at the time, a current task, he could keep up with it. So for example, if someone read him a phone number, he could recite that phone number. However, none of these new short-term memories could be transferred to long-term memories. So if you asked him the phone number the day after, he wouldn't know the phone number anymore. So he could no longer make long-term memories. A few other things were still intact, so his long-term memory prior to the surgery was still intact, so we do call that retrograde amnesia. So he could remember his childhood, who his parents were, where he had previously worked, his name, stuff like that. His IQ was also still intact, and then he still had the ability to speak, and his vocabulary was unchanged. And like I said just a few seconds ago, he was unable to make new long-term memory. Because of HM's memory issues, they put him to a couple tests and tasks to figure out more of what's going on and to learn more about the condition that they had caused. One of the tasks that they did was called the mirror tracing task. So his job was to trace a star on a piece of paper while looking at a mirror. So he wasn't looking directly at his tracing, he was looking at a mirror and trying to trace the object. What they found in the results of the study were very fascinating. So on day 1, he had multiple errors as he did the task a number of times. I believe it was about 10 times. By the second day, they found that he had actually made less errors than the day prior, and still on the third day, he had made less errors than the day before. Remember his memory issues. So he only had his short-term memory intact and could not make long-term memories. So he could listen to the instructions the day of and follow the directions and task at hand. But by the next day, he had no idea what the task was or what he did the day previously. Despite those memory impairments, we still saw that he had less and less errors over 3 days. The mirror tracing task helped us to really understand what's going on in his brain and what happens when we perform this type of procedure. Let's break it down. What did all of that mean, right? Because his errors declined, but he didn't know what he did the day previously. So this indicates that his procedural memory was still intact. So remember in about 2 videos ago when we talked about procedural memory being a form of long-term memory. Procedural memory is a type of unconscious long-term memory that we don't have to think about. So for example, brushing our teeth or walking, we don't have to think about those tasks. This same type of concept is used for this task because he had less and less errors every single day, and it was more so that muscle memory that we talk about. So, what are scientists able to hypothesize about this? So perhaps the hippocampus is not involved in procedural memory. Remember the things that were taken out of his brain during the surgery. Is it really that simple? Science tells us no, it's not that simple. But it does indicate that other areas may be more involved, such as the basal ganglia or the cerebellum. I hope this video was fascinating. Follow for more.